Right, good morning. Today we are doing percentage yield. This is quite a straightforward one today, which you'll be pleased to hear. So what we are looking at today, as I've just said, is percentage yield. So percentage yield usually follows a quantities question. So before the Easter holidays, you looked at quantities or reacting masses, where you had two sides to an equation and you had to work out relative formula mass, and if I had 20 grams of one, how much would I have of the other? If you can't remember, you might just want to look back at your notes. So this would always follow that question. So the questions that I've given you are examples of sort of what you could expect if you got both numbers. A big exam tip for this one is that if they talk about percentage yield and they haven't given you a sort of before and after number, so you don't have two numbers in the equation, or the question, sorry, what they would do, or what you would expect to do, is get your previous answer. So whatever you've had previously, that's what they would be looking for. So just a little exam tip. When we go back over, sort of when we look at this in terms of revision, I'll show you some examples of exam questions. So percentage yield is a percentage, so the actual mass of the product divided by the predicted mass of the product times 100. Or, as I always teach you in science, whenever you're working out a calculation or a percentage, small divided by big times 100. We've done it in physics when we're looking at efficiency and things like that. So small divided by big times 100. There are sometimes questions that are theory based with this one. So the first time we've had a little bit of theory for a while. Why might it not be a 100% yield? So we might predict 100 grams, but we might only get 90. Why might that be? And there's three main reasons. Okay, so the first main reason is we have an incomplete reaction. So not every atom reacts. The second reason is that different products might form during the reaction. So we're basing this calculation off this set reaction, but it might be that a different gas is formed or a different product is formed. The final one, the third one, is it's a practical loss. So we're not collecting all the products. If you put down that we didn't filter it properly, that would be an adequate mark for that. So incomplete reaction, different products forming, or a practical loss. So those are your three reasons we don't get 100%. So looking at how we actually work it out then, so a calculation predicts that 619.7 grams of a product should be made, but only 598.7 grams were made. What is the percentage yield? So we do small divided by big times 100. So we've got 96.6%. Okay. Second question, so 927 kilograms of iron oxide were produced, oh, that's my bad, ignore that, produced, which was only 13 kilograms less than predicted. What was the percentage yield? Apologies for the fact that I've got scribbles and incorrect things here. I'm running out of paper. So again, we do small divided by big, but we've got 13 and 927. So don't get caught out by this. It says produced, which was only 13 kilograms less than predicted. So our predicted was actually 927 plus 13. Okay, so our predicted was actually 940. Our actual was 927. And to get it as a percentage, we times it by 100. .6 reoccurring percent. Nice and straightforward, this one today. You shouldn't have any problems. It is just small divided by big times 100, but just make sure you've got a note of these bits, please. Have a great day, and I will speak to you all tomorrow. Bye.